5, Absolute Value Inequalities, Day 3. Our essential question today is, how do you write an absolute value inequality when given a graph? So we've worked with solving absolute value inequalities and writing out our solution inequality and graph. Now we're going to be given a graph and we are going to figure out how to write that absolute value inequality to go with our graph. Okay, so our first one, write an absolute value inequality for each graph. The first thing that I want you to remember is that when it is an interval graph, it's going to be a less than or equal to absolute value inequality because we're talking about the distance away being less. So that means that it is closer to you if the distance away from you is less. So what we're going to do is we're going to find the midpoint first because that is the number that we are finding the distance away from. So the midpoint of this graph is -1. And then we're going to find the distance away from that number in each direction. So the distance away from -1, it's 1, 2, 3 units away. So my absolute value inequality should be x minus, because distance you're subtracting, x minus -1 is less than or equal to 3. I used a less than or equal to because we have solid circles on our interval. You can simplify by making that a chunky plus, and this is my final answer. The absolute value of x plus 1 is less than or equal to 3. Okay, our next one, my midpoint. My midpoint is 2. And the distance away is 3 again. So that means the distance away from 2 is less than 3. It's less than 3 units away in each direction. And on this one, x minus 2 because it's a positive 2 and you subtract. So this one is done. And I used a less than symbol because it has open circles. Okay, my last one. The midpoint is 1. And the distance away on this one is 2 in each direction. So, x minus 1, my midpoint, is less than or equal to 2 units away. Now we have 2 rays. So I'd like to remind you that 2 rays means that we will have a greater than or equal to absolute value inequality. My midpoint on this one, my midpoint is 0 because it's in the middle of the 2 rays. So midpoint is 0, and then the distance away from 0, 2. So, the absolute value of x minus 0 is greater than or equal to 2. So it's 2 or more units away from 0. So I can simplify this one because the distance away from 0, x minus 0 is just x. All right, my next one, I have a midpoint of 1. And the distance away in each direction, 2 units away. So, x minus 1 is greater than 2 units away. So on this one, what changed I have the distance away from 1, so x minus 1, and then it's greater than 2 because it's an open circle. All right, my last one, my midpoint on this one is -4. And my distance away from that in each direction, it's just 1 unit away. So, distance away from -4, so x minus -4 is greater than or equal to 1 unit away. So this one simplifies to be x plus 4 is greater than or equal to 1. So the distance away from -4 is greater than or equal to 1. Okay, now we're going to write an inequality and graph the solution on a number line. A survey showed that the president's approval rating was 63%. The margin of error was 5%. Okay, so the approval rating was 63%. But the margin of error, what that means is that it could have been off by 5%. And it's pretty typical for survey results to have a margin of error. Surveys are never exact. They're never exact. They're always estimates. So margin of error was 5%. So in each direction, I have to go 5%. So what that means is that the president's approval rating is actually somewhere from 58 to 68%. It's anywhere in this range. So 5% margin of error means we've got to go 5% in each direction from 63. So here is my graph. Here's my graph. Now to write an inequality for this, the distance away from 63% is less than or equal to 5%. So it's less than or equal to 5 in each direction away from 63. Okay, write an inequality and graph the solution on a number line. To fly a kite, the wind speed must be within 5 miles per hour of 11 miles per hour. So within 5 miles per hour of 11. So that means I have to start with the 11 miles per hour. And I have to be within 5. So that means 5 to the right, which would be 16. 5 to the left, which would be 6. So just like the last one, it's going to be this interval from 6 to 16. So I'm not even using the 11 as one of my endpoints in my graph, because when it says within 5, it means it could be 5 in either direction for your kite to fly. It doesn't have to be 11. It's got to be 6 to 16 miles per hour. So write an inequality and graph the solution on a number line. So we've got our graph. Our midpoint is 11. So x minus 11 is less than or equal to 5 in each direction. All right, the next one. Write an inequality and graph the solution on a number line. The speed limit is 65 and the minimum is 40. So what that means is the maximum speed is 65. The minimum is 40. So I'm going to go by 5s here. This one's a little different than the last one. Okay, this one's a little different. So what this one is telling me is that 40 is your minimum, 65 is your maximum. So this is the graph that would represent all of the acceptable speeds. Now, I don't know the midpoint. I don't know the midpoint on this one. So to find my midpoint, I'm going to add together my two endpoints and divide by 2. I'm going to average them. So 65 plus 40 is 105, divided by 2 is 52.5. So my midpoint here is 52.5. So the distance away from 52.5 is less than or equal to. Now I need to figure out how far that is from this endpoint over here. So 65.0 minus 52.5, 10 minus 5 is 5, 4 minus 2 is 2, 6 minus 5 is 1. So the distance away is less than or equal to 12.5. That would be my absolute value inequality. You should be able to write a summary now. Make sure that you are using complete sentences in answering your essential question.